I just wrote another version of recursive grep based on total distress and anxiety. And I actually experienced this before. I talked about it quite a bit in videos 104 through 106 when I was talking about BackgroundWorker, and especially the three routines of BackgroundWorker: do work, run worker completed, and progress changed. And the solution actually is totally different than the videos 104 through 106. In those I was building a background worker from scratch, and here I have all the code written, and what I really want to do is put a background wrapper around part of the code, a background worker wrapper. And that's one of those things that requires a lot of thought and not that much code, since essentially you're just using the same code and putting the wrapper around it. So the first thing I had to do was drag a background worker over to the form, and that put the background worker component in the component tray, and I renamed it to BGW for background worker recursive search. And then initially that's on the properties, and I changed the reports progress to, I left the reports progress to false, but I changed the worker supports cancel to true, because one thing I want to be able to do is cancel a search. And if I try and do that, or if I try and basically do anything with this form the way it was before this version, this is version 9 and version 8, like I initially foolishly tried to select part of something that was displayed on the screen and copy it to the clipboard, and that caused the whole program to gray out, and I couldn't stop the program, and I actually couldn't run all kinds of other things on the computer. It actually felt like I'd caused the computer to hang up. So once again, the background worker inspired by anxiety. But once I created the background worker component just by dragging it over, I went over to the events, and the two events I was interested in is do work, which actually creates a background thread, which unfortunately can't access the UI. And the other one was run worker completed. And run worker completed and progress changed both run on the same thread as the UI, so they can access it, but they're very limited in their capabilities. Do work is really where everything happens. So if we double click on do work, you see I essentially added very little code. I have this the do work, which basically gets a string from e.argument, where e is the do work event args, and then calls the same function I've always had, the file search recursive, with that directory name. And the only difference is, instead of calling this function directly in the button event handler, I call BGW recursive search dot run worker async, and I pass the directory name to the thread that I'm creating with run worker async. So I've commented out the old code, and the reason I don't need the end search is that's handled in the run worker completed. So I have the background worker recursive search run worker completed that just calls end search. That's all it does. And this event handler itself is caused automatically when the code in do work finishes. But while we now have file search recursive running on its own thread in the background, so I can do things with the UI and it won't hang everything up, we now have a new problem, because one of the main things that file search recursive does is call list hits with the directory, and that basically prints out to the multi-line text box any hits we find that match the search string we put in. It basically converts everything to uppercase and then compares the search string to the current directory file entry. And if it exists, before what I did was I did a text box of pen text with the current file name, and then I updated the text box right away so you can see results occurring. But we can no longer do this because the thread that contains file search recursive and indirectly contains list hits is now running on its own thread and it can't access the UI. So I created a new routine called print hit. And this is another thing I had to do a fair thinking about. At first I was going to put this whole thing in something that tests for whether or not we need an invoke. And if I did that, it would be a disaster. We'd miss all kinds of things and we'd start over and do all kinds of weird stuff. Well, what we want to do is minimize the amount we put in this routine, the print hit, and basically all that does is it checks the text box results and a boolean that says does it need an invoke. And the fact is, when it's running on a different thread, it will need an invoke. We won't be able to run this code because we can't access the thread that owns the text box. So this is not true. Basically, it says it doesn't need an invoke, and in fact it does need an invoke, so it goes to this code, which basically creates a delegate with the function print hit, which is a type of recursion. Basically, it's a way of calling ourselves again, but instead of calling ourselves in a conventional way, we create a delegate and then invoke the delegate with this.invoke, and we pass the parameter of the file name that was the hit as the new object array with an initializer list that contains that name. So basically, the first time we call this, we need an invoke, so we go to this code and then we invoke ourselves, and then the second time we call it, it comes through again and it says, do we need an invoke? No, we don't, because we're already calling ourselves with an invoke. So now we can add this line to the text box and update the text box. So essentially I just copied this code from where it used to be down here, and I created the delegate in order to do an invoke in order to use this code. So we can now access the user interface controls that are running on a different thread from the main file recursive thread. And the delegate itself is defined up here as delegate void del print hit. Print hit is the name of the function, and I just had del to indicate that it's a delegate. And the main thing with a delegate is the function signature has to match the real function that you're putting in the delegate list, because delegate is really a list of functions that get called. You could have quite a number of functions. And so void is the return type and string is the parameter type, which exactly matches the real function, which is print hit, which is a void, and a string is the parameter type. So we can create this delegate and everything works correctly, and then we do the invoke, and first time through we hit here, second time through we hit here. So we ultimately update the text box in a two-step tick-tock type motion. Probably this print hit is the most code I actually added. Everything else is like replacing two lines with one line. You know, the wrapper is very little code, but as I say, a lot of thinking. So if we compile and run this and say I look for GUID gen, which actually was what I looked for when I had the disaster, and we start from the root directory and I hit search. It takes a while because it's searching an entire 2 terabyte disk. Actually it doesn't, because it did it before and I think it caches that. But you can see the information being printed out to the text box, and even while it's printing I can do things like highlight this and do a copy and then bring up a text box and paste it to the text box and do all kinds of things with the UI even while the program's still running. You notice we haven't hit the end routine. We just hit the run worker completed and printed out this text box from the run worker completed event handler of the background worker. So this now works great. This works exactly the way I want it to. And it's was very little code and a lot of thinking. So you might want to play this video more than once to pick up on the subtleties of it. I hope you enjoyed this video and learned a lot, and I'd appreciate it if you'd subscribe.